Managing a single Docker node and maybe a couple of containers on your laptop, well, that's one thing, right? But managing a bunch of nodes and tens or hundreds of containerized apps? Wow, that is a whole nother thing, believe me. Well, enter Docker Swarm and Kubernetes. Here's the plan. We'll paint a big picture. So what's all this orchestration about, and what's a swarm and what's Kubernetes? Then we'll do a bit of a deeper dive into a swarm cluster. Then we'll build one. And proper secure, right, with encryption, mutual TLS and all of that jazz. Then we'll look at orchestration, but just a bit, right, because we've got a whole module on that later, but it'll be a good primer. Then we'll finish up by doing our usual of reminding ourselves the stuff we've forgotten. Now then, if you're studying for the Docker Certified Associate exam, you're going to pick up the following, right? In Domain 1 under Orchestration, complete the setup of a swarm cluster with managers and worker nodes. Demonstrate steps to lock a swarm cluster, and paraphrase the importance of quorum within one. Then under Domain 5 Security, describe mutual TLS. Alright, buckle up. I want to keep this short, okay? It's a deep dive course and I'm hoping you've already got the basics. Anyway, Swarm is the future of Docker. Seriously. Now, I know that might sound weird, especially when Kubernetes is looking for all the world like the industry standard orchestrator for containerized apps. And don't get mad at that if you love another orchestrator. It's just an observation. I mean, feel free to disagree and I'm happy to have it out on Twitter. Anyway, despite the rise of Kubernetes, including its native support in certain versions of Docker, Swarm is absolutely still at the heart of everything Docker is doing. Stick with me for a second, alright? The reason is, Swarm has two parts. The secure cluster part and the orchestrator part. And it's this secure cluster part here that is absolutely central to the future of Docker, especially Docker Enterprise Edition and the higher level stuff that's going on there. Okay, I get it, Swarm's obviously not even a factor in the lower level stuff like Containerd and the OCI, right? But the higher level value add stuff, including native support for Kubernetes, Swarm is front and center. So that's the clustering bit of Swarm. The orchestrator bit, okay, that's maybe not quite as strategic. I mean, it's not about to disappear, so don't panic if you're running it in production. It's just going forward, it's my guess, right, that the Swarm orchestration bits are going to give way to Kubernetes. Anyway, the secure clustering bits, absolutely key to the future of Docker. But that begs the question, what is a secure Swarm cluster? Well, at the highest level, it's a cluster of Docker nodes. We've got managers and workers and everything's secure. So we've got mutual TLS where workers and managers mutually authenticate each other and all of the network chat is encrypted. Plus, the cluster store is encrypted and it gets automatically distributed to all managers. And we can use labels to tag nodes and customize the cluster how we want it. Anyway, once we've got the cluster, then we can start scheduling containers to it. So instead of running individual Docker container run commands against specific nodes and every time having to think about which node we should be running them on, well, instead of that, we just throw commands at the cluster and we let Swarm decide. So Swarm does all of the workload balancing and the likes. Great. Well, we can run two types of work on the cluster, native Swarm work and Kubernetes. Though, at the time of recording, right, you can only run Kubernetes work on Docker Enterprise Edition. That might change, I know that. I'm just saying for now, if you want Kubernetes on Docker, it's gonna be Docker Enterprise Edition. But that's the big picture. A Swarm is a secure cluster of Docker nodes. I don't know, right? Kinda like a giant Docker node. In a way of sorts. Anyway, once we've got it, we run work against it. Native Swarm or Kubernetes. Pretty sweet. Okay, now that we know the basics, let's peel back the covers on the clustering side of things. Alright, first up, Docker is a set of nicely packaged tools. If you pop the hood, you're gonna see a bunch of smaller tools. Docker just bundles them and wraps them in a slick API. So stuff like the Moby engine and Containerd, runc and SwarmKit, they're all separate tools, right? But bundled and slightly integrated for that slick Docker experience. Magic. Well, one of those smaller tools is SwarmKit. It lives here on GitHub, and importantly, it's what powers Swarm mode. Swarm mode. What's that then? Okay, back in the day, Docker had this separate orchestration piece called Swarm. You'd install Docker, then you'd lay a Swarm on top. It was okay, as long as you didn't mind frying your brain configuring it. The thing is though, it kinda led to a separate toolkit called SwarmKit. The idea being to build and open source all of the smaller component tooling so that people can pick and choose what they want. Okay, well, in Docker 1.12, SwarmKit got integrated into the overall Docker package. I mean, it's still available as a separate toolkit. It's just, as of Docker 1.12, it's fully integrated into the Docker engine. The point being, right, ever since 1.12, Docker's had this notion of single engine mode and swarm mode. Single engine's where you install individual Docker instances and you work with them all separately. Swarm mode, though, that's where you bring them all together as a cluster. And like we've seen, we can start throwing work at the cluster instead of having to handpick a node for each and every container. Brilliant. Well, for some people it was. Others, let's just say not so much. Anyway, look, any node running as part of a swarm cluster is in what we call swarm mode. Not in a cluster, single engine mode. So let's go through building a cluster. We've got a node here, Docker installed. Throw a simple command at it, and presto, we've got a swarm. And that node now is flipped into swarm mode, yeah? Now then, behind the scenes, oh my goodness, there's a ridiculous amount of magic just happened. You see, this node's now the first manager of the swarm, and the first manager in any swarm is automatically elected as its leader, and that makes it a bit special. For starters, it's the root CA of the swarm. I mean, you can configure external CAs if you need, just pass in the -- external CA flag. But if you don't, this one gets the job. It's also issued itself a client certificate, built a secure cluster store, which by the way is etcd, and that's automatically distributed to every other manager in the swarm, and it's encrypted. And all of this for free, right? As in, we didn't have to do anything, it's done for us. Including a default certificate rotation policy. Epic! Oh good grief, there's more. It's also created a set of cryptographic join tokens, one for joining new managers and another for joining new workers. So let's join a new manager. We take another node running Docker in single engine mode and we run a Docker Swarm join command on it. We give it the crypto join token for managers and that's it. It's part of the swarm and obviously operating in swarm mode. And see how the cluster store's been extended to it. Oh, and it's been issued its own client certificate, right? That identifies who it is, the swarm it's a member of, and its role as a manager. Sweet. Same again for a third. Now then, the picture's getting a bit busy. There's a lot going on though, so stay with me. Swarm managers are automatically configured for high availability. So any of these can fail, right, and the cluster keeps going. Behind the scenes though, only one of them's truly active, and that's the leader, which is important, right? Every swarm has a single leader manager. The others, we call them follower managers. It's Raft terminology if you know your Raft. Anyway, when you issue commands at the cluster, go ahead, you can issue them at any of the managers. It's just if you hit a follower manager, it's going to proxy commands to the leader. Now, if and when a leader fails, we have an election. And as with all elections, the one with the biggest budget wins. No, I'm just kidding. One of the followers gets elected as a new leader. But all of this is handled by Raft. So within a swarm, okay, all the distributed consensus stuff is done by Raft. The same as Kubernetes actually. Raft's the go-to solution for distributed consensus these days. Now then, the ideal number of managers is 3, 5 or 7. Any more than 7, And you can end up spending more time thinking about decisions than actually acting on them. It's like deciding what to eat. If there's a handful of you, it takes 2 minutes. If there's 20 of you, man, you can kiss goodbye to half of your night arguing. And it's the same with Swarm. So 3, 5 or 7 for managers. Just make sure it's an odd number. That increases the chances of achieving quorum and therefore avoiding split brain. You know, where you've got a network partition or something and you end up with an equal number of nodes on each side and a stalemate or a split brain. Neither side's got the majority or quorum, right? So updates stop happening. Badness. We don't want to go there. So, an odd number. And, actually, 1 is better than 2. 2 just increases the chances that one of them will fail. And when it does, it offers absolutely nothing to help. So yeah, 1, 3, 5 or 7, but preferably not 1. Now, as cool as Raft is, right, it's not a fan of slow or unreliable networks. I mean, who is, right? But this is important. Connect your managers over decent, reliable networks. So for instance, okay, and this is just an example, if you're in Amazon Web Services, don't go putting them in different regions. Across availability zones within a region, that's probably all right. But going cross-region is just asking for pain. Okay, well look, adding workers is the same. Docker Swarm join again, only this time give it the worker join token. And we can have a mix of Linux and Windows. Great if you're running hybrid apps. Now when you join a worker, it does not get access to the cluster store. That's just for managers. But what each worker does get is the full list of IPs for all the managers. So if one of them dies, the workers can just talk to the others. Oh, and they all get their own certificates, right? Gosh, I hate this diagram. I hope it's valuable, because it's ugly as heck and it took hours to create. Anyway, like with the managers, the certificate identifies who the worker is, the swarm that it's a member of, and what its role is. Worker, yeah? Now then, the workers do all the application work. And on a swarm, that's either native swarm work or it's Kubernetes. And we'll look at these in more detail later. But I think for now, that's a swarm. A cluster of managers and workers, a full-on PKI where the leader manager is the root CA and it issues every node with a client certificate that gets used for mutual authentication, role authorization, and transport encryption. I love it. And on top of that, we've got a distributed encrypted cluster store, cryptographic join tokens, and loads more. And the best bit? It's all just built in and works out of the box. Take a minute to let that sink in. I kid you not, it's something special. Secure out of the box and easily configurable. Thank you, Docker. And I don't care if that makes me sound like a fanboy. That is genuinely some seriously good stuff. Enough